Hello, this is Rob, Alpha Hotel 6 X-Ray, and today I'm going to provide a little demonstration of the AntScope2 software by RigExpert. Most hams have RigExpert handheld devices, but not all of them have used it with their AntScope software. And so it's an easy connection using a USB cable between your device and your computer with the AntScope software loaded. When your AntScope is connected, you'll see the single and continuous buttons here illuminate, and that allows you to, from the software, do a single scan or a continuous scan using your analyzer. And then that data will be graphed on the screen rather than being graphed on your handheld device. And you can see that the screen is a much bigger display and provides a lot more data than the little handheld display. So let's get started. So today I'm going to talk specifically about the SWR chart that you're seeing now. And so on the left-hand side, you can see SWR values of 1 through 10. So when hams talk about a 3-to-1 or a 5-to-1 or a 10-to-1 SWR, that's the left side graph here. And then on the bottom is the frequency range. And so all the gray sections that you see are the amateur radio bands. So 160 meters, it's probably 20 meters. This is 40 meters. This is 15 meters, 10 meters, and this all the way up here is 6 meters, and then lots of other ham bands in between, right? And so in order to change what you're looking at, range-wise, you can go up in the top right-hand corner and set, let's say, 1,500 or 15,000 for the middle of the HF band, and then we'll set a range of 15,000, and that'll get me centered. And then you have number of points. So I think the maximum is 1,000 points. And so that's how many sample points it's going to take for the given range that you've specified. So in this case, from left to right, I'm looking at 30 megahertz worth of bandwidth, right? So 400 points over 30 megahertz, the points are going to be spread apart quite a bit. And so you could do up to 1,000 points, and that would give you more points, but still plenty of distance between the points. Or you could do a smaller range, right? And so a smaller range, more points, gives you more fidelity of data, right? Better resolution of the data. So what's nice in this software is that if you have a particular range that you're looking at, you can go ahead and save it using this add button. And so, and it saves it across runs of the software. So I don't have to do anything special to save that is now in there. Next time I open the software, it'll automatically be in there. And so if I want to look at 20 meters specifically, I can go 14,175, and then we'll go 200 either way. And now I'm just looking at the middle of the 20 meter band. And because I've specified 200 either way, that's 400 points. So I'm going to get a sample at every point through this current display. So high resolution data, right? And then this is a popular window or view for me to look at. So I'll go ahead and add that. And so now that I have two shortcuts, I can look at all HF, and then I can look at just 20 meters. And so today I'm not going to connect my RigExpert device. I'm in the house. But I am going to go ahead and open up a file with some data. So I recently created a 20-meter dipole, an inverted V, using a QRP Guy's 1-to-1 voltage balun. And so in this particular exercise I was doing, I wanted to see the effect of the angle of the inverted V as that changed my resonance, right? So, and the way I would change the angle is by having more or less guy line. So essentially in the triangle, the more base you have on that triangle, the larger the top angle is, right? So the guy line I started out with was 16 feet long. So I'll go ahead and take a look at that data. And so what you're seeing here on the display is what was recorded at the time I recorded it. So the system doesn't have any way to create data that you didn't record. So because I saved this file, this is all the data the file contains. But it's relevant for whatever I was looking at the time. So let me go ahead and zoom in on 20 meters. And you can see like a little bit of chop here with the cursor. That's just because when I recorded this, I just didn't record it in the exact same view at the exact same amount of points as I did last time. But pretty good resolution of data, right? So again, this is 16 foot worth of guy line. So I'm going to go ahead and open another file where I used half as much guy line, right? And so this is where the software really shines. So what I'm doing now is I'm comparing, in this case, two configurations of the same antenna, but you could configure, or rather compare multiple antennas this way as well, or multiple operating locations. The point here is that you can load multiple scans on top of each other so that you can do a comparison. And so the green line right now represents 16 foot worth of guy line. So that's kind of a bigger angle at the top of that triangle for my inverted V. And then this is half, the red line represents using half as much, right? So what does that mean, right? So as a ham, if I want to do digital modes or CW modes, the further my radiating elements are off the ground, or the larger the angle is at the top of my dipole, right, the lower the resonance is going to be. So if I want to work FT8 or I want to do CW, then I want to get those radiating elements up into the air, and one way I can do that is using more guy line, right? By comparison, if I want to do just strictly sideband, then I might use half as much of my guy line, right? And that's going to put me more resonant on the top end of 20 meters. And so I don't like to carry a ton of gear when I'm out portable, and so I chose to do 2/3 of the guy line. So in this case, the orange, right, was my third attempt, and so that's resonant more or less in the middle of the 20-meter band. And so doing these three samples and comparing the three here, like, it's taught me something about the effect of resonance as it relates to the angle of my inverted V, how far my radiating elements are away from the ground. It's allowed me to performance tune my dipole, right, and make sure that I'm using the right amount of guy line for the mode that I want to operate in. So I'm going to go ahead and clear all three of these and show you. So that's a comparison of the same antenna used in slightly different ways. So I'm tuning an antenna in that case, right? So now I'm going to compare my KM4 ACK antenna, which is an end-fed, and full HF. So one of the things the software will do is when you load a file, it's just going to give you a range that you're not maybe super interested in. And so in this case, it's gave me a lot more range than I actually recorded, and so using those shortcuts are super handy. Anyway, so right away, I can tell that this KM4 ACK antenna is resonant on 4 bands, right? So it's resonant, no tuner required, on 40, 20, 15, and 10 meters. And then with a tuner, I could even do 160 meters with this antenna. So I'm getting 4 bands, no tuner required, and it's handheld, right? It's a very small antenna. So anyway, I want to compare this to my PAR end-feds, 10, 20, 40 trail-friendly end-fed. So I'm going to open that up. All right, and so again, let's reset the range. And so in this case, the PAR end-feds in red compared to my KM4 ACK end-fed, which is easy to differentiate the two. So first, I'm getting maybe a little worse SWR, like a little worse performance in the PAR end-feds in the 160. And then you can see here that 40, the bandwidth, right, of the PAR end-feds is very narrow compared to the KM4 antenna. So, and the main reason here is that the LNR Precision PAR end-feds antenna uses a coil in order to give you 40 and still keep the radiating element short. And so the coil really, really tightens up the bandwidth there. And so the PAR end-feds, turns out, has a little bit better bandwidth on 20. Maybe that doesn't matter so much when you zoom in, right? They're almost the same. It gives me none of 15, and it's a little low on 10. So one of the things hams will do with their antennas, right, is trim them in order to make them resonant. So the thing is that if I wanted to make this antenna perform a little better on 10 meters and I shortened up the antenna a little bit, it's also going to pull my 40 and 20 over, right? So then I have to decide, do I want to operate primarily in 10 or 20 or 40, because shortening that antenna is going to affect residents across the board, right? And so again, this is the kind of stuff you can do in the software that you'd have no ability to do on your handheld device. And then you can also take this data, save it, and then send it to a friend or post it online and provide a lot more interesting data to the community or your friends for comparison's sake or education's sake or what have you. Anyway, if you have any questions, go ahead and send me a message. I'm on QRZ. This is Alpha Hotel 6 X-Ray.